So hello, good afternoon, and welcome to a new Rhino user webinar. This time we have Krzysztof Wojslaw with us, and he's going to talk about why every engineer should use Grasshopper. But as my colleague Guillermo Varela organized this webinar and contacted Krzysztof, I let him introduce the speaker. So thanks, Guillermo and Krzysztof.
Hello, everyone. Thank you, Carlos, and thank you, Chris, for accepting our invitation and for being here today. Well, Chris is a bridge engineer who works for applying computational design in different disciplines of the AC industry. He has worked for the engineering company Sueco, and I think he's going to show us some of the projects he has done there. Also, he is co-founder of the blog beamcorner.com and the newsletter learngrasshopper.com. Now he's working on a Grasshopper learning platform where all engineers can start with parametric design. Instead of learn by watching, the platform is built on the rule learn by doing, where students need to solve real work challenges. I will send you the link to check out this exercise that I have been able to try, and I think it's a very interesting and different way to learn how to use Grasshopper. Remember that this webinar is being recorded, so it will be available on YouTube right after it finishes, and also that you can post your question for Chris in the chat, and we will answer them in the last 15 minutes after his presentation. I will now post some links in the chat related to Chris and this webinar that you can check. Well, thank you again for joining us. And Chris, please start the presentation if you're ready.
Yes. Hello.
Thank
you. Can you see my screen? Let me see.
Yes.
Yeah. Hello, Carlos. Hello, Guillermo. Thank you for having me. Thank you for invitation. It's a pleasure. It's a pleasure to speak on the McNeel Europe official channel. So today I will present my work that I've been doing in some of the Sueco work, some of my personal use cases, and try to answer the question why engineers should utilize the power of Grasshopper. And I will try to debug one of the biggest myths about parametric design, that Grasshopper can be applied just by architects. So today will be lots of examples, lots of practical examples, and really many different disciplines. So for those who haven't heard about me, don't know who am I. My name is Krzysztof Wojslaw. I'm Polish. However, last 8 years I've been living in Norway, and last 5 years I work as a bridge engineer in Sueco, one of the European biggest consultant company, where I work as a parametric design specialist. So at the beginning, my job was to introduce parametric design in the bridge department. However, afterwards, I tried to implement parametric approach in really different disciplines in the whole company. I'm also an academic lecturer in the Global Master's program at the Ziggurat, when I also try to share my knowledge about virtual design and construction methodology, and try to also show how BIM and parametric design can be applied to the work. Speaking about knowledge sharing, as Guillermo said, I'm a co-founder of Beam Corner blog. We are 6 Polish engineers working in Norway, in Oslo, actually working with different kind of BIM. However, we are trying to write on our blog a practical approach, how it can be used. I'm personally responsible for parametric design part, and on the Beam Corner YouTube channel, you can find a lot of practical tips and tricks, how to use Grasshopper, how to fight with spaghetti monster, or how to work with data trees. So I really recommend for those who haven't been on YouTube by Beam Corner to watch that series. And the last thing that I'm glad to share with you, this year I decided to resign from my permanent work. I work more now as a freelancer. And in addition, I'm a founder of learngrasshopper.com platform. So this platform that I'm working right now, it will be aimed for learning engineers, like practical approach, how to learn Grasshopper and how to use it at the work. So for now, It's just a mailing list on the learngrasshopper.com, where already 5,000 engineers are registered, where every Friday I'm trying to share materials, where to start learning, what is the best tips and tricks, how to work with the program. So every time I'm trying to share what I've learned in the last 5 years. So if you haven't signed up, just do it right now, learngrasshopper.com, and you will get emails from me and updates if the platform will be already finished. So it was quick introduction about myself. Let's go and answer a question why we should use, as an engineers, parametric approach. So at the screen, you can see right now, like in my opinion, 5 most important reasons why engineers should apply parametric approach. So first of all, of course, changes. So every designer has experienced that for sure on every project. It can be called modification, difference, transformation, variation, etc. However, I found the one name for all of that changes. It's a nightmare. It's really nightmare because sometimes this kind of change can destroy whole your project, and sometimes you need to start your work from scratch. So what we should do, we should hear the advice of this guy. So we should prepare our models for this kind of changes. So that's why the parametric model are the best for that, because you can see what kind of changes, you can predict what kind of changes there are actually coming. So if you are not sure if a road line or building area is defined, so actually you can make your parametric model with these parameters, because it's hard to make 100% parametric model. Sometimes you need to predict some parameters and just apply that. So we know that changes are coming because every designer has experienced that. Now we need to prepare our models. I have prepared some graphs, some schematic description of a project. So this is like on the X axis, we have time. On the Y axis, we have completion of a project. So with the starting phase and the finishing phase. So this is a traditional way of working. When changes occurs, so as I said, it can destroy our project. So from the finishing phase, we can come back to the project's starting phase, and then we are just our delivery, it will be much, much longer. However, if you see on this graph that's showing parametric project, you can see that the design can be done much quicker. So we can come to the finishing phase a little bit faster. However, there will be change. So anyway, really fast, we can come back and finish our project much earlier. However, now I will show you the third option when we have already parametric tools ready. So you will see that if we have already parametric tool created for specific task, so actually you can see the curve starts really going really steep up and going really fast in the finishing phase. And the same as it was with the parametric approach, we can easily come back to our finishing phase. So the first reason was about changes. The second one, the complex design, this one is really liked by architects, especially because when you write parametric design in the Google, so if you Google it, so you will see these crazy shapes, crazy fronts, facades, buildings, lots of operas, lots of really nice futuristic shapes. However, if you look closer, for example, on the road line, some people think that the road line is just a curve. However, if you look closer on that and you explode it in the parts, you will see that you have circular curve, you have transition curve, clotoids, where the slope of the road is changing. Sometimes also the width of the road is changing. So we can also tell that this geometry is also complex one. So I'm work as a bridge designer. So we always try to design bridges on the straight lines because of this reason, because to avoid these clotoids, these transition curves. However, when I see all the pictures of the bridges from China, I can tell that Chinese engineers has a rule that they are building bridges just on curves. So you can see Guiyang City in China or Nanpu Bridge in Shanghai. So there's just curves, just a clotoid. So, and Grasshopper for this kind of geometry can be applied as well. So not just only facades and complex geometry of furnitures, but however, infrastructure project has also a lot of complex design. The next one, of course, integration. Grasshopper has a lot of to offer, and as you can see, there is just a small amount of programs that Grasshopper and Rhino can be connected. Every month, I think, is coming a new connector. However, if we look on this workflow, so we can see on the top left corner that we have input data in form of Excel, in form of AutoCAD file. We have also point cloud or IFC file. So everything actually can be imported to Rhino and Grasshopper, of course, with some additional packages, for example, IFC with some additional programs. However, you can manage that. Afterwards, we only have our models in the algorithmic platform, so we can export it to the structural analysis program. We can also like FEM design, sophistic, RFM. There's really lots of good connection and actually works pretty well. I will show you some examples. Detail calculation, there's connection to idea statica, when you can send your connection between all two columns or two beams and then make a calculation of that connection and send real results, come back to your algorithmic design. There's also visualization connection with Twinmotion that I will show you today. And of course, data analysis and 3D models. So there's a Tekla, Archicad, which was one of the first connection to Grasshopper for the 3D models, and of course Rhino inside Revit, when you can apply also Grasshopper into Revit. The fourth reason why we should use a parametric approach is a model-based project. So in Norway, there is more and more projects that actually are delivered without drawing to the site. So as centuries, we done drawings, like paper drawings, and from these 2D drawings, we build structure like 3D object. Afterwards, when the software were developed and we get soft to create 3D models, so we have started to prepare our buildings, our bridges in the 3D model. However, afterwards, we changed that up. We changed this 3D model to 2D drawings. We project that on the 2D plan, and from to this 2D plan, again, we build a structure. So you can see there's 2 steps, and in this workflow, you can easily make a mistake from making drawings from 3D to 2D or building at the site from 2D to 3D. However, now with the development of BIM and the newest technology, so actually we can build just model-based without using a drawing. We're sending just the IFC files, and contractor can take all the reinforcement bars, all the coordinates by himself at the site. So now, to deliver a project to the approval in Norway as a bridge project, you really need to have really strong arguments to deliver it with drawing. Actually, almost 90% of projects are delivered based on the model. And why we need Grasshopper in that case for this model-based project? So in the drawing world, it's kind of easy to cheat a little bit on the sections. So for example, if you make a section of a bridge deck of a building, So sometimes you can just hide some things, you can cheat a little bit on the sizes. However, in the 3D world, when you deliver something like 3D model at the site, you cannot cheat. You need to deliver 100% everything correct. So if you, for example, delivering 3D model of road line or like edges of a structure, so everything needs to be really accurate. The same with reinforcement. Back then, on the drawing, we could just write a comment that this solution for reinforcement should be applied on every column. Now we need to actually model that reinforcement in every single column. So this is the reason why we need to apply Grasshopper, because we need to deliver more accurate 3D models. Okay, and the last reason, of course, automatization. The Grasshopper gives plenty of possibilities to extend design approach. So to connect to more advanced scripting languages like Python or C#, or to make automatization for the standard solutions. So actually we can make our work really faster and in the proper way, so we can avoid this manual work, working like with the same solution, the same standard solution several times. We can automate that. And today I will present some automation examples, how it can be applied. So these 5 reasons: changes, complex design, integration with several softwares, model-based project it's showing, like Norway example from Norway, showing that industry will go in this direction, delivering to the site just 3D models without drawings, because it's showing lots of time savings and less errors on the side, and of course automatization to make design faster. All right, back to agenda. So now let's go to some examples, and now I divided examples by discipline. So there's several disciplines that I will show you some examples how Grasshopper was used on the several projects. So let's start maybe from not the most obvious one, which is road and rail design. So on the screen, you can see a program which is Quadri. It is a common data environment, which is like have a IFC and DVGs model from different disciplines. You have a road designer, architecture, structure, bridges, and so on. And actually you can find the live connection between Quadri and Grasshopper. So here from common data environmental, you can with the live link, you can load the latest road line and get it directly in your Rhino. So in your Rhino model, so as you can see right now, it's a like standard approach. In Grasshopper, you can define your vectors, define your planes, and in this case, we are building a barrier. So the barrier is building from the different libraries. So we can divide the line by the barrier's columns, and afterwards you can define the shape of the whole barrier and define whole the length. At the end, it's with the point with the definition of how it will look like the ending of this barrier, and we can apply the same on the another side. So afterwards, we can export that barrier to the Quadri, and what is the advantage that it will be a native object. So actually, we export it as a solid object, and actually we can get all this data in the Quadri. Here is the example with the curb design along the road line. It's really simple example. However, it just shows you that you can extend possibilities of your software. There is like some road or railway projects or softwares that actually has some limitation. Here, with some additional scripts from Grasshopper, you can add a really easy curb with all the materials that are defined with the gravel, and maybe calculate the volumes. And this is approach that actually can change the way that road engineers are actually working nowadays. So it was about road and rail design. So let's go to bridges. And I'm really glad to present Ranselva Bridge, the project that I've been working as a parametric design team lead, where it was 5 people working just with parametric, with Grasshopper and Tekla, to get this 3D model of this bridge. So we finished with 70% of the objects that was modeled in Tekla through Grasshopper. So all pre-stressing cables, lots of reinforcement, whole geometry of a deck, railways, and and we get it from Grasshopper scripts through to Tekla. And in 2020, this bridge get a prize for award from the best beam in the world. So just showing that this approach of working, can give a really good results in the beam models. So let's take one of the example how we can automate reinforcement creation in this whole big deck. So on the screen, you can see cantilever bridge for those who are not familiar with this kind of structure. So we are building a column with the concrete, and from that column, from the top, we are building in the cantilever method segments, one for each side. So afterwards, we are building, bridge is growing to connect that with the another side when also is doing with this method. So as you can see, there's lots of parameters defining this deck. So as you can see on this cross section, so first of all, we have variable heights. So each segment has a variable height. So it will be different from the start and different at the end. Second parameter is that there is a different thickness of a deck. As you can see, there is a bottom line, which are defining by one parabol. However, you can also see that the top of this bottom deck is also defined by another type of parabol. This gives us that every single segment has also variable thickness. And the third reason that I already said to you, bridge is in the curvature, vertically and horizontally. So this all gives us a really hard geometry to model. However, it gives also a lot of possibilities to use Grasshopper for creation of reinforcement. So now I will show you a video that's showing how reinforcement can be built from Grasshopper. So now you will see the bridge deck, this cantilever part in Tekla, and this is a BRAPS representation in Rhino. So from that point, we are searching for surfaces, and now we will create some stirrups. So from these surfaces, we extract lines. From lines, we are dividing lines to get the points, and from points, we are creating our stirrups. So here you will see that we have created all different stirrups all along the bridge deck. So you will see that this export as a bridge reinforcement stirrups in different colors because we have really different segment in that bridge. Another example will show also stirrups, however, in the walls. So the same pattern, the same rule can be applied. So we are finding surfaces, dividing, extracting lines, dividing this line to points until we get stirrups. And again, you can see now that every single segment will have has another number of reinforcement in that segment. We are staying with the bridge design. I was playing a little bit with to get a visualization rendering in the Twinmotion, and there is also connection from Rhino to Twinmotion, and I will show you that example how you can make your parametric design and to render it directly through connection. So here there is a connection through Rhino to Twinmotion. I will really quickly make an asphalt of a deck between, like in the valley, and you will see that it was if there's object which is baked in Rhino, so actually you can get this 3D geometry. So I'm modeling some abutments and clicking on the synchronize button, so you get this abutments in your Twinmotion directly without creating any files. And of course, it was manual work. You can open your Grasshopper and you can use your prepared scripts for deck creation or the bridge creation. So here there's another cantilever bridge, so you can just synchronize, and actually if you created your parametric model that you are baking automatically your design into Rhino. So actually you can create this great renderings. Afterwards, you can add another bridge on the side, make some vegetation, add some trees. So you can actually make a design of your construction in the Twinmotion. So with all parameters, all the scripts that you used, for example, in the another soft. So here is example. I just play a little bit with vegetation. I just add some vehicles, some river, so you can really get really fast, nice results of visualization. So it also can be really a good way of using the Grasshopper scripts and just to render them with a Twinmotion engine. All right, so let's go to the next one. We stay with the structures. Here on the Ranselva bridge, I will show you how steel core piles were modeled. So from the script, you just choosing your foundation, and the pile and will be created with some parameters that you can define. The gray surface that you can see on the screen, this is a bedrock. So every time when you move some sliders parameters, you can adjust the length of these piles. And what additionally was really great here, that we would like to export some info about length, about the angle between pile and between the bedrock surface. So actually we could, from Grasshopper, we can send it directly to the IFC. So to get this all information in the object through Grasshopper. Additionally, we also made a test to connect this to the FEM design, when you can make, you can send the data of the piles like geometry, and actually you can test with all the calculations. Actually, you can define the geometry of the piles. However, you can also define all the loads that can be in the analytical models. So this connection with the FEM design, we tried it several times and it worked really, really well. The next discipline, electro, it's coming maybe to be used more and more, especially in the infrastructure project, however, and the buildings as well. Here is just a definition of the lightning post. Of course, you can have lots of products. However, I made just for fun, just one example of lightning post. So you can create your own geometry, how you can define. Maybe you can also download from website some of the supplier, and that lightning post can be applied through Quadri, this common data environment. You can load your road line, as you can see right now, send it to Rhino as a point, and then you can generate all the lightning posts through all of the whole of the road line. So we're defining our planes, and afterwards with the standard design, we are orienting our lightning posts. So in the easy way, we can get the really equally distributed lightning posts along the road line, and we are sending data as solids to quadri, and we get at the end the really nice lightning posts from script. Geotechnics, there's plenty of application how it can be used. Every single company has this kind of Excel of calculation. In this example is a reinforcement of a ground. So there's calculation, lots of parameters, and in the end we get the form of a table. So with our results, and I move all this calculation to Grasshopper. So every single parameter what was in the Excel actually was moved to Grasshopper, and actually at the end we can get the same calculation, the same numbers with the, and also we can export in the Excel data and get the same results. So with the Excel right, so actually we can go to our Excel and get the same form as it was in the previous Excel. However, there's this approach is better because you can actually make a step further and actually connect this Excel, which is in the Grasshopper right now. You can connect to your 3D model. So here is an example. There is a portals and there is a retaining wall with some additional ground reinforcement. So actually this ground reinforcement now is connected to calculation Excel, which is in the Grasshopper. So you can apply your geometry in the real life and the same, send this data to your common data environment. Tunnels, there is lots of tunnels in Norway. Actually, before this webinar, I checked that the total length is more than 800 kilometers. So every single tunnel needs also a portal. So portal is this kind of structure, which is a little bit wider at the beginning. The reason for that is that when you're driving really fast, so you are not feeling really at your driving through a really narrow tunnel. So it needs to be wider due to safety reasons. So in Norway, road administration standardize all the types of tunnels the same with the portals. So actually you have a table with all of these different parameters. You have some width, you have the different radiuses where to start this defining portals. And actually it's just showing a perfect example how this standardization can be used. So let me see, I will just jump to, just let me see, I will come back to this example. Something's not working. Right, okay, so let's go. This is one of my first projects actually done with use of Grasshopper. So here, the definition of profile. So there is you saw lots of circles, lots of lines that are crossing each other. So actually in this way, you are defining your parametric model. So you are changing the width of a structure of a profile. You can just make some changes in the inclination. So here in the portals, we have different profiles which are aligned on the line through the road line. As I mentioned, to make it more safer, that you have a wider opening. So after alignment, you are connecting all these profiles together to create a really nice BRAP. In the same, you can all the parameters for changing because you don't know actually where this tunnel will start. And afterwards, you're just sending this 3D model from Rhino to Tekla. And now you will see on the right side Rhino with road line and white point is just a start of a portal. However, now you can see that changes are not a nightmare anymore. So with every change, with every movement of the road, you will see that this portal is moving along. Even though if you would like to change from the straight line to a curve, so you will see that this portal is moving along as well. So you get also this really fast, this 3D geometry. And again, we have the whole model in the Tekla. So now you can see that all the parameters about size, about the thickness can be applied. So this is perfect example how standardization, how the standard solution can be optimized through Grasshopper. And of course, you can make also take a one step further and make reinforcement as well for this standard design. All right, the last discipline that I consider really interesting and should begin to use Grasshopper is a beam coordinator. Actually, with Rhino 7, there is one really useful component, which is called clash. And there you can find the clash between points, between lines, meshes, and B-wraps. So actually, lots of input that you can actually check if there's clash or not. On the screen right now, you can see that there is some lightning posts going through the road line, and there is some portals underneath. And actually with just a red sphere, you can see how many clashes are there. So now I just changed the design of the distance by 2 meters for lightning posts, and you can see 4 red spheres with just a quick note that there is some collision detected. So it's really a nice way to just check it, to automate your work, to not checking that if there are some clashes visually, and to make your design without any clashes. So you can see there's some chainage intervals and chainage start that will change, and you will see that there is no clashes detected. So you can just write your own program just in Rhino and Grasshopper and to see if there's any clashes or not. So actually that was the last example that I would like to show you today. And now, for sure, you are just thinking, okay, Chris, you showed me lots of amazing examples how Grasshopper can be applied. However, for example, for sure, you, Carlos, you get this question all the time, how to start with Grasshopper, and actually
many times.
Yeah.
But before you jump to this point, maybe we can. There is one nice comment by Pedro Luis Iserte.
Yeah, sure.
He knows you, right? Because it's long time no see. And he's wondering if you have any specific workflow for road design or railroad design involving either cut and fill or design with lines, arcs, clothoids.
Yeah, so we already made some tests for, as I showed you with the barriers. We actually made some for railway design. So actually it was a problem in the software that all the fillings, that there was 5 railways going next to each other, and there was 5 fillings next to each other, and where they were crossing. And actually the problem of the program, like a standard program for rail design, that this program does not calculate this volume of all these fillings. However, we made as a 3D meshes that in Rhino, and actually we get this result. So actually in this case, we just use it as an input from the 3D DVG. We modeled all the fillings and we exported that as a 3D mesh with the object, and we get real data. So yeah, there's lots of workflows. However, it's just additionally software that can help you with some particular cases. So for now, Rhino cannot be used as a whole road design because you do not have these standards and this kind of all this like engineering stuff. However, it works perfectly when you have some limitation at your software and can be used for that.
Thanks.
Is there any more questions that I can answer?
Well, there are many people saying this is an excellent presentation and demonstration. And Shoibs is asking, I want to understand, after completing modeling part with Grasshopper, if we can produce the construction documentation to all level of information. So documentation, I guess, if you can also document your projects, full
Yes.
documented.
So as I said, in Norway, there is more and more. We are actually skipped a lot of part of making drawings. So all the documentation that we are doing actually is in the 3D model. And of course, like Grasshopper can be used for that, to put all the information in the BIM model through parametric approach.
Okay, and one more question, but this is maybe more for the end. But well, that Keith Lorit says that too often he runs into limitations with the functionality offered in, I guess, in Rhino Common or in the commons. So maybe with the components, how can we get into the Python-based guts of Grasshopper Rhino to extend its functionality? So I guess he wants to learn more about Python coding in Grasshopper.
Yeah, this is like natural step. It was also for me. I'm also started to learn some scripting languages, because you're coming to some limitation, and with C# you can write some your own plugins, and yeah, for sure it's it's extending.
When the spaghetti becomes too you need some coding there, right? And last one before you continue. From Luftudursun, I'm a structural engineer using Sophistic daily. So I think he wants to try Rhino and Grasshopper with Sophistic. There is also a link. I think you have more experience with Tekla rather than with Sophistic, or have you tried Sophistic as well with Rhino?
Yeah, I have actually my master and bachelor thesis, it was about Sophistics. I really know pretty well this soft. However, in the one point, I was more focused to Tekla. However, we in the company, we have tested connection with Sophistics. So actually you can make a really good design of all the design of the 3D and send it to Sophistic. So actually there is lots of to use Grasshopper. So yeah.
And are there any examples on your websites? Or...
No, actually no with the Sophistic. However, I'm going to work on that. So it's coming some Sophistic. However, I can really recommend Guido. He works in Sophistic, and he has also a blog. Maybe we can link here as well. However, he has like lots of experience and showing examples how Sophistic can be used. Yeah,
contact us by email, and we will put you in contact with the Sophistic team and Sophistic experts, because there are also many recorded webinars on the internet. And one more question about the Ranselva Bridge. By Francesco Randazzo. He asks if all the rebars were clash-free, so no concentration at all between rebars.
This is really good question. Yeah, actually, our principle here was to deliver to the site a clash-free rebar IFC of the rebar, and actually we get it. Of course, there was some maybe small clashes together with pre-stressing cables, because there is a really difficult geometry, and you cannot just sit there and try to fix all the clashes. However, we delivered whole the module as a clash-free, because it saves a lot of time at the construction site. So in Norway, there's a 1 hour at the construction site costs a lot. So every hour that someone construction site needs to wait or make some fix some clashes costs a lot. So that's why all the designers put a lot of effort to deliver without clashes.
Yeah, and actually it's a little related to next Shoib's question, is how the contractor can exactly complete construction without drawings. I mean, he understands how good the digital BIM model is, but for the construction, it's difficult for him to see how people could work there without drawings.
Yeah, it is. It was for me. This question was the same, and at the beginning, how contractor can change, like from the really conservative industry, change to digital models. However, like already 5 years of experience in Norway just show that like some computers and tablets can be used at the site in really harsh condition in Norway in the sun. No, not much sun, lots of rain and snow. However, there is like a BIM kiosk, so like a BIM station where you can go to the building or a container and just show your model. You can create some 3D print screens from the 3D model, and then you can use that to build.
Okay, nice. And the very last question before you continue, because otherwise we will be stuck here. This one by Felipe Alvarado. If you have any specific workflow or tutorial for steel plate connections, like pin or bolted, same as you show on foundation plate sample.
Yeah, actually in Tekla, there is lots of possibility of automatization, and I actually tried to make welds and bolts make together with some components, and it works really pretty well. And I haven't tested Idea Statica connection to calculate that. However, my colleagues get a really good result and actually send it through Grasshopper to Idea Statica and get the results of calculation of that one and come back to Tekla and apply this solution. So yeah, it's possible, and actually many companies is starting to work with this workflow.
Perfect. And well, one nice comment by Sophistic North America. Chris, let's talk and collaborate. If you don't know them, I can put you in contact with them.
Sure.
Why
not?
We've done some workshops together with Verena Fogler and Sophistic. Okay, we'll let you continue. And if there are more questions, we'll leave them for the very end.
Yeah, just a 5 minutes that I would like to mention. So the question, where to start? So where to start applying this crazy algorithm and how to learn that? So actually, my usual answer is, this is how I learn Grasshopper. Go to YouTube, check really nice examples, which are you really interested, because this is a thing. You need to be interested in the topic and just to find out something and try to do the same. There's Rhino can be downloaded for free. There's 90 days free version, and together with lots of books, guides, you can really find lots of knowledge for free. Even I have prepared my own guide, 5 steps to learn Grasshopper, which was downloaded more than 8,000 times. So it just really shows that it's really lots of people just wondering how to learn this parametric new method of design. However, this is one problem with that actually when you're looking for some knowledge in Google or on the YouTube, you're actually finding 1,000 of great examples of architecture on design site. So there's plenty of futuristic shapes, like lots of textures. On the right side, you can see right now a tractor point. One of the first that I actually started learning, and actually I done example with the attraction point for those who haven't heard about that. So you're defining your point, and actually when you are moving that point, you're changing whole geometry, whole the pattern. And actually I showed to one of my colleagues, look how good, an amazing example. And it said, yeah, great job. However, how can you apply that on the bridge modeling? So actually it was true. There is not so many practical knowledge, like showing like buildings, structures, this kind of things. That's why I have decided to make my own platform for that. And I have like two things in my mind when I'm creating these platforms. First of all, first rule, that it will be engineering approach. So the plan is to make lots of practical examples with lots of structures, lots of bridges, staircases, buildings, maybe some of the pattern finding, and actually how to learn in the practice computational thinking, because this is the first step to learn how computers thinks, and afterwards apply that on the stadiums or another buildings retaining walls. And another thing that is in back my head when I'm creating this platform, I'm really fan of the method learn by doing. Actually, so when I have learned 5 years ago Grasshopper, I watched one tutorial, I made the same steps as the teacher made, and okay, I sat in front of the computer, and okay, I'm going to make the same, but without the help of a teacher from YouTube. And actually, I couldn't use any component, because this is not the way I like to learn, because I really quick forget, because I'm not trying, I'm just repeating someone else's work. So that's why in this platform, I'm going to create more than 300 exercises that actually going to follow students how they supposed to be supposed to be solved, and they will show you if you're going in the good direction or not. So here you can see on the right side, this is a counter. So you can see how many answers are correct, how many not. On the end, you can see results, how many are solved. So let's start with the first exercise, which is download and install MetaHopper plugin. So all this system for this document is based on the MetaHopper plugin to change some colors and make this interactive. So here on the cluster, so you can find the answer. When you click on the button, so you can find MetaHopper, where it should be downloaded, which version. So afterwards, you can go to next step, which showing that you should unblock your properties in your plugin. And afterwards, if you click on the button, you can see how it should be installed. It's just a drag and drop function of MetaHopper to these Grasshopper files. So my approach was to create exercises that first of all show you if you are going if you solve it correctly, and have this solution in this script. So here is an insert curve closest point. So you're looking for curve closest point, and you will get results. You will see that the results change. So you're correct. So you can go to the next one. Here is an example how you align parameters vertically. Of course, you can do it manually. However, it says here in the exercise that this column should be equally distributed. So everything needs to be equally distributed. And for that, you need to make a combination of some of the clicks and buttons. So here, with just clicking on the button, so you will see that it was equally distributed and it's approved, and you can go to the next one. If you don't know how to solve it exercise, you can go to cluster, double click on that cluster, you have an action, what should you do, tip, and solution. If you click, there is a video that actually showing how this slider should be created. So afterwards, you're creating your slider, change some names, and connect to checker. And actually, it will change color for green, and you will see results. So this is my idea of creating this platform. I'm trying to also prepare some more fun examples, because it's not just about Grasshopper. We have to know about something about Rhino. So in this exercise, you need to make a line, make a curve through all the doors, and you need to make this curve through all the doors. However, you cannot go twice through the same doors, and you cannot cross your path. So this is kind of exercise for Rhino to start also to learn how to use Rhino at your work, because this is also necessary thing when you are would like to be master your Grasshopper. So these exercises are now officially available. You need to go to Grasshopper Fundamentals.com. and you can download it and test it. I'm really curious, what do you think about these exercises? So go to grasshopperfundamentals.com, click download. If you downloaded these exercises, you will sign up. So I will let you know when the platform will be finished. So as I said, I'm in the process right now of creating 300 of these exercises. And if you like it, just write to me, Chris, at learngrasshopper.com, and show me your results. So that was all for me. If there's any more question, I'm really glad to answer that.
Thank you, Chris. Yes, I'm checking here all the questions. I think everyone was really impressed by the examples that you saw, and they are asking about what, or explaining what they are doing. For example, working with Rhino inside Revit and Dynamo. Yeah, and I think the next question is from Sven Amiet, and is asking how are construction enterprises using models to build? Do they extract drawings themselves or sending model data to machines? I don't know if you answered this one.
I answer a little bit this question.
Okay.
I can answer also about some bending, a rebar bending list, because now there is a new format, BVBS format for bending rebars. And actually, now it's also becoming a standard that to the construction site, we are delivering a BVBS format shape code for bending of reinforcement. So this kind of information in the IFC can be extracted and actually can be connected to the bending machine at the factory. So no longer we are making bending drawing lists. We are just adding some extra information about this BVBS format. You can just Google. It's a German standard for describing a bending rules, and this one can be used for machines in the automatization.
Great. Okay, we have another one from Mateo Strella. He's asking if you think it's a good solution using Grasshopper or Rhino inside Revit to automatize drawings.
Yeah, not indirectly in the programs like Revit or Tekla or Archicad. However, you can automate your drawings if you create your drawings in Rhino. So actually, you can make some templates. I saw many examples. Mm-hmm. And I think it was in the previous webinar, it was also about creating drawings of the plans of the buildings. So yeah, there's plenty of possibilities to make automatization of drawings.
Yes, we had that webinar with the plugin Plan Finder. Yeah, that was something similar. Well, here Beam20 that's saying it's Fouad from AFAG Paris. If you can tell us about the automation of attributes in Run-Selva Bridge and the important number of attributes to fill in on the elements.
Mm-hmm. Yeah, really good question. So for sure, like revision number, it's really good first parameter that you can automate. However, the most important ones, it was the poor faces. So like the faces, how you're going to construct. So actually kind of 4D in the IFC model. So actually you're adding some what is the next step of building? So actually we try to make or to implement this kind of faces in the class of the reinforcement in the Tekla. So for example, the first layer of reinforcement of foundation, it was class 101. Second layer, it was 102, and so on. So you can build that. So afterwards, it was easier to contractor to just go, okay, what should I do? He is on the site and actually in this container with his model, and actually he can check on the classes which reinforcement should be placed first, what is the second step, and so on. So this is really one of the, I think, most important parameters that we implement. And the same, if you see this example with reinforcement in the deck, so actually you give this attribute as well. So this kind of how this structure should be built. If you can just compare this, I will compare that to instruction from IKEA for the furnitures. So actually you make this also like a phases how this should be built, and just clicking on the particular class, it should be say, okay, it should be put in that order.
Okay, we have another comment from Mateo Strela. He's saying, I'm responsible for parametric models and it's a lot of fun doing it because of quickness, but the drawings unfortunately is quite complicated to do in parametric way connected to a 3D model. I'm not sure who it's exactly the complication that he's having, but I see that you, for example, start with just a curve or a line, and then you create the parametric model from there.
Yeah, this is the best thing. Like, try to find out what is hard to fix with the general software that you have, and try to implement some small step. Maybe in my case, it was one of the bridge deck that was actually extended at the end, and it was lots of limitation back then in Tekla. So it was one of my first application methods, and I just applied it for this particular case, not for all the bridge, because you cannot start making your model whole parametrically. Just start with the small steps.
Okay. Then we have a lot of people thanking you for this presentation, and
I'm really glad to be here. So
yeah, saying how practical, clever, very intricate design approach. And also some more questions from Francesco Randazzo that is saying, can you show some script example for a pre-stress cable and how you insert the end anchor of pre-stress cable?
yeah, I do not have like a pre-stress cables. However, I will show you the same approach that was actually applied in the, let me see, I will just show. Yeah, we can just go to next question. So in the meantime, I can find the answer for that one.
Okay. Okay, we have Kate Loris saying that he's looking forward to use Rhino and Grasshopper for cool application related to synthetic biology and advanced simulation modeling projects. So a different kind of works.
Yeah, this is a little bit different, different field.
Yeah, for sure. Joel Albuquerque is asking if Rhino and Grasshopper is an option for timber construction. I don't know if you have an example for timber construction, but I think it's a great tool.
Yeah, it's a great tool as well. However, I haven't worked with a timber. We've done some bridges with a timber structures. So actually, yeah, we've done this. And there's one department in Sweco that actually is doing that in Revit. So actually, it was possible to do that, this timber design as well.
Yep. And the last question from Paulo Colombo is, what's the best way to export plots and graphs from Grasshopper? And thank you for the webinar.
Can you repeat the question?
Yeah, what's the best way to export plots and graphs? That I'm not sure who is referring from Grasshopper.
Plots and graphs. Okay, yeah. I think there's a one plugin. I don't remember how it's called. However, you can just write me for chris@learngrasshopper.com. However, there is one plugin. So actually, it's I think it's one of the dinosaur name. I do not remember which one exactly, so I don't want to make you wrong. However, if you just write me an email, so there is one good one, like you can present all the graphs and in Grasshopper.
Yeah, I'm trying to find it, but I can't find.
Is it pterodactyl? I think pterodactyl.
Let me check.
Yeah, I think they can they can write either Chris or us for the last questions, because we are running out of time. But many thanks, Chris. It was a pleasure. It was amazing. I think, as you mentioned, there are a lot of examples on the internet for architects, architectural modeling, timber construction, Voronoi, attractors, etc., but not as many for engineers. And this is why your website and experience is great for us here to show. We've organized another webinar in a few weeks with another engineer, this time from Rumble, if I'm not wrong.
Yes.
We will announce it shortly. And many thanks again, and hope to see you soon physically.
Yeah, we hope to
we met sometimes in the past.
Yeah, you're welcome in Oslo. Maybe it will be another parametric design seminar. So you are welcome. So again, thanks for invitation. It was great to present my experience, and I hope that
thanks to Guillermo for the organization.
Yes, it was really perfect organized, and I hope that many people can now solve these homeworks and exercises. I'm really looking forward to get some responses if they solve it or not.
I'm sure they are all visiting your website now.
Yeah.
I hope that too. So let's stay connected.
Okay, thanks everyone. Have a nice evening, and see you in a few weeks with new webinars.
See you. Bye-bye.
Thank you. Goodbye.
Bye.